Alright. What's up mga chimek nyo? Na-miss nyo ba si Sir Jello? Na-miss ko rin kayo and na-miss ko makita ang sarili ko dito. Alright, so somehow I managed to get a little... Quiet lang kayo. So yan, it's almost 10 p.m. so hihinaan ko lang ang boses ko but hopefully it's still audible. Ayoko makagising ng mga tao sa aking paligid. So anyways, as promised, no, I'll be giving you the answers and I'll walk you through to the solution of the gas problems or gas law problems that I have uploaded in preparation for your exam. So hopefully you tried them so that you can check, if you get the correct answer. So these are your problems. So I screenshotted them na lang dun sa sa PDF file that I have uploaded. So let's start without further ado with question number 1. Sige. So an oxygen cylinder used for breathing has a volume of 5.0 liters at 90 atm pressure. What is the volume of the same amount of oxygen at the same temperature if the pressure is 1.0 atm? Hint, would you expect the volume of gas at this pressure to be greater than less than the volume at 90 atm? So first things first, before we answer anything here, let's try first to write the given, no? If it will help, we can also draw or sketch what's happening. So kunwari nakatulong sa akin ang may drawing kahit ang pangit ng drawing ko. So this is an oxygen cylinder used for breathing, no, underwater. Currently daw, this has a volume of 5 liters. Alright, so the volume is 5 liters, 5.0 liters. Lagyan natin ng backpack para kunwari pang scuba diving siya. Hindi yan hindi yan thermo. That's a backpack. An underwater tank. Sige, 5.0 liter. That's the initial pressure. And the pressure here is 90 atm. So the initial pressure is 90 atm. It's very realistic because it's being used underwater. So, nasa baba siya. Now, what is the volume of the same amount of oxygen at the same temperature? So, meaning, here constant ang ating temperature. Also, constant din ang amount of gas, no, our N. So, what is the volume of the same amount of oxygen at the same temperature if the pressure is 1.0 atm? So our pressure dropped to 1.0 atm. What would be the final volume? Alright. Sige. If you tend to memorize formulas, you will easily realize that this is the Boyle's law, where PV is given and the temperature and the number of moles or the amount of gas is constant. But then again, some of you during the first day, and I'll never forget it, hated chemistry because you don't want to memorize. So again, in chemistry, we don't need to memorize. So, though at least we need to memorize one, especially in gas law. So we just have to remember the PV and RT and the technique, in order to use this for all the gas laws. That's why it's magnificent, it's elegant, it's a one of hell of an equation, is to simply isolate what is given. Given ang P and V, so we isolate it to one side of the equation. And here, voila, it's already isolated. The PV is on the other side. So next step, after isolating it, remove the unnecessary variables and then simply mirror what's on the left side to the other side, and then assign initial and assign the final values. Again, sabi ko nga, some books would use A, B, some would use I and F for initial and final, but for our uniformity, that's 1 and 2. So P1, V1 is equals to P2, P2. We are looking for V2, so we manipulate the equation further before substituting. Now some students would automatically substitute. No, that will still be correct, but I don't think that's neat. So we cancel first. Alright, so that's P1 V1. I'll divide both sides by P2 so that I'll be left with, yan, na-miss ko ganito gamit ang mouse. I'll be left with V2, and by associative property I'll place it on the left side. Then I'll have P1 V1 is equals to over P2 rather, and then I can now substitute. Hopefully you can follow. V2 is P1 V1, that is your 5.0 liters times your P1 is 9 ATM. So na-interchange ko pala 90 ATM, but that's fine. The 90 ATM, yan, medyo mahirap pa rin talaga, mas madali pa rin ang marker. And the P2 is 1 point, pero nakakangalay naman nun maghawak rather ng cellphone. So ATM will cancel, so we'll be left with liters as unit. So that's over 1, so we simply multiply 5.0 liters times 90. So I think we don't need calculator for that, because 5 times 9 is 45, no? So it's 90, so that would be 450. So 450 significant figures. When multiplying and dividing, we copy the list significant figure, so that would be 2, 1, 2. This is 1, no, actually 1 lang, siguro 9.0 ATM to or ewan, pero since it's 90 ATM, it should be 500 liters kasi 1 significant figure lang, no? But for the sake of this one, no, two significant figures natin, hindi, 1 significant figures lang talaga siya. Let's follow the rule, so that would become 500 liters. But then again, the more accurate is 450 liters. Following the significant figures, which we have to, is 500 liters. Alright? So that's your volume. Si hint dito, would you expect the volume of gas at this pressure to be greater than or less than the volume? Since they are inversely proportional, of course, if we decrease the pressure, the volume will increase. Alright? So hopefully you get that. So this is your Boyle's law, volume and the pressure relationship. Alright? So let's proceed with number 2. And for this time, matatagalan masyado tong pag-solve natin. I will no longer illustrate. So imagine nyo na lang that a sample of hydrogen gas at 273 Kelvin has a volume of 3.2 liters at 4 atm pressure. What is the volume of this pressure if it's increased to 10 atm and if the pressure is decreased to 0.70 atm? Now this is kind of tricky, because first let's try to write the given. We have a temperature given, that's 273 Kelvin, and 3.2 liters, that is our volume. So 3.2 liters. We also have our pressure, which is 4.0 atm, and we are looking for the volume. The volume, one of the volume at, if pressure is 10 atm, if P2 is 10 atm. So sana ma-interpret nitong pinagagawa ko. So this is the volume if our pressure will change from 4 to 10. And what would be our volume? So pwede ko siyang V 2.1 or V3. These are just label. Question mark if the pressure is 0.70 atm. Alright, first things first, you might think that we are given PVT, so we'll be using the combined gas law. But notice, on the other side of the problem, there is no change in temperature, no? Though there is no given temperature. So we will assume that the temperature is constant. So again, be mindful kasi some problem might trick you na, or baka malito ka na, bakit may temperature dito tas dito wala. So meaning it's simply constant. No? So this is at constant temperature. And of course, since walang number of moles or amount of gas, we assume that N is also constant. So these are constant. So we are also given P and V. So this is again Boyle's law. But again, we use the same equation, PV and RT. Isolate PV since we already know that would be P1 V1 is equals to P2 V2. Let's solve first if the P2 is at 10 atm. So the V2, we already manipulated that on the first item. That would be P1 V1 over V2. V2 will be 273 3.2 liters. This is our V1 3.2 liters. Yeah, sorry sa medyo magalaw ang mouse. And 4.0 atm. Alright, 4.0 atm over 10 atm. 10 atm. So we'll be needing calculator here. That's 3.2 times 4 over 10. So let me use this online calculator. 3 para nakikita nyo rin. 0.2 times 4, 12.8 divided by 10. Oh, mali. That's wrong. Ulitin natin. 3.2 times 4. Sige, equals muna natin. 12.8. Answer divided by, bakit ganito? 12.8 na lang natin. 12.8 divided by 10. So that's 1.28. Alright, the volume here would be 1.28 liters. 1.28 liters. Alright, second, if the pressure is 0.70 atm, so gawin ko rin itong V3, pero again, that's just the final pressure. So same formula, I just write here para di maki-oras. That would be 12.8 atm. 12.8 kasi 3.2 times 4 lang din naman atm. Makisama ka naman marker, digital marker. This is 12 ba? 12.8 atm over 0.70. 0.70. Since this is 10.0 atm pala, cancel. Significant figures here is 1, 2, 1, 2, 1, 2, 3. That's two significant figures. This is 1.3. Right? 1.3 liters. 1.3. Yan. Sorry kung ganito yung sulat, but hopefully nalilisten nyo naman. You can listen to the things that I'm saying. So, yan. 0.70 atm. So, 12.8 divided by 0.7. That is our, right, hindi ko nakita 12.8. Pakagamit ko kasi nitong online calculator. 0.7. That's 18.28. or 29, 18.29, but the significant figures are 1, 2, 2, so two significant figures, that is 18.3, 18.3 liters. Alright, since the pressure decreased, the volume would increase here. That is your Boyle's law, 18.3 liters, or simply 18 liters since I have two significant figures. Alright, that's 18 liters. That's your answers for item number 2. Hopefully you get it. Item number 3. Let's use a blue marker. A sample of chlorine gas has a volume of 0.1. As what temperature in degrees Celsius would be required to increase the volume to 1.0 liter, to decrease to 2.0 liter. So there's a lot of things being asked here. No? It's a lot of step to do. So let's begin with the given volume. Initial volume V1 is equals to 0. Bakit nawawala ang dot? Okay, 0.30 liters. Temperature is 273 Kelvin. So temperature is 273 Kelvin. Pressure is 1 atm. Alright. Pressure is 1 atm. And then, if you will check the problem, you'll realize that there's no change in the pressure. So this is a constant. So pressure is a constant. So lagyan natin ng PC. And the number of moles of gas, or the N, is also constant. So we are given V and T. And that would give us Charles's law. But again, if you don't memorize the formula, don't you worry. We can manipulate the equation after we seek for what is required. So the required here is the temperature. Now what would be the temperature T if we will place it more accurately, if the volume is 1 liter, 1.0 liter, and what would be the T at 0 if the volume is 0.20 liters. So kanina kasi ginawa akong T2, T3 or V2, V3. So ito mas accurate na pag describe sa kanila. Alright. So that's V1, T1, and we have the temperature. So again, if you don't know or if you forgot to memorize, but since we have the internet for your exam, but this is a skill you have to learn nonetheless. So PV is equals to nRT. We manipulate the gas loss by isolating the given to the left side and eliminating the unnecessary. So we have V and T. I'll transfer T here by dividing it by both sides by T. So T would cancel here. It's on the left side, and P is unnecessary and R is unnecessary. So I'll be left with VT. I'll mirror it to the right side. Alright, there you have it, no? Assigning initial and final value. Without knowing it, you have the Charles's equation at constant pressure and constant number of moles. Then I'll substitute or manipulate first to have to get the final. So multiply both sides by T1 and T2 on the multiplicative inverse. T2 here on the other side as well, T1, and then T2, cancel si T1, and then here T2 will cancel, so I'll be left with T2, V1, and maski saan sana natatapon ang digital cursor. And here I'll be left with V1, T1. And to isolate the T2, I'll divide both sides by V1, V1, and I'll get here, dito ko na, that would be T2, T2, cancel, cancel, T2 is equals to V1, V1, T1, yeah, hindi kumakagat, V1, T1, and then over, I'm sorry, this is V2, so this is V2 over V1. Alright, all I have to do is to substitute. No, the V2 is 1.0 liters. Sige, yan, sobra-sobra na. Ang equals 1.0 liters times the temperature is 273 Kelvin. 273 Kelvin, and the volume is 0.30 liters. It's getting messier and messier. 0.30 liters. Alright, let's input that in our calculator. 1.0273, so that would be just 273 over 0.33. 273 divided by 0.30, that would be 910. 910 Kelvin. 910 Kelvin. Alright, so maybe this is an internet problem, so I'll just answer the first four and I'll upload the last four tomorrow. 910 Kelvin, but it is in pressure, in Celsius rather. So to get the Celsius, we subtract it with 273, so 910 minus 273, that would be 637 Celsius. So this is 637 Celsius. That's too hot. No, it's beyond the boiling point. 6 times 637 degrees Celsius. So I'm having a rough time here, no, and it's causing too much time. So what you need to do for the second one, no, the T if V is 0.20 liters, is to simply substitute the value here of your V2. Alright? Can you do that on your own? Yeah, hopefully you can. Okay, last item muna, and I'll record tomorrow because I'm having trouble. So, yan. Driving on a hot day causes tire temperature to rise. What is the pressure inside an automobile tire at 45 degrees Celsius if the tire has a pressure of 30 psi at 15 degrees Celsius? Assume that the volume and the amount of air in the tire remain constant. So, let's have the given pressure. Alright, may initial pressure tayo na 30 psi. So I forgot the conversion table. So psi to atm, that would be baliktad, 1 atm to psi, and that is 14.7. 1 atm is 14.7 psi. So 30 psi divided by 14.7, 30 divided by 14.7, that's roughly 2.04. No. So let's use ATM. Ayaw talaga. 2.04 ATM. And then our temperature is initial temperature natin. No. Though nasa last part siya ng problem, siya yung initial natin, no, if you analyze the problem well. 15 degrees Celsius plus 273, that is 288 Kelvin. 288 Kelvin. So 15 degrees Celsius plus 273. So 288. And then we have the final temperature T2 at 45 degrees Celsius. So 45 plus 273, calculator na natin. 45, baka mali pa. 45 plus 273, that is 318. So 318 Kelvin. 318 Kelvin. And then we are looking for the final pressure. So what is the final pressure? So volume and amount of air, or N, is constant. So again, if you memorize the gas laws that I have discussed, you'll understand that this is the Gay-Lussac's law. But again, we don't need to memorize PV and RT. You know where would this go? Isolate by the given on the other side. TT, cancel. You'll be having PT. No, we don't need this. So that would be PT is equals to, mirror it on the other side, PT, assign values 1, 1, 2, and 2, and then manipulate. So we are looking to P2, so we multiply both sides by T1, T2, or cross multiply, and that's your favorite, P1, T2. Sige, para makita pa rin, para sa nahihirapan pa. Alright, P1, T2 equals to P2, T1. Divide both sides by T1, so you'll get P2 alone. Okay, T1, cancel, and you'll be left with P2 is equals to T1, T2, T1, and that would be, direkta na natin, 2.04 ATM, 0.04 ATM. Yan, nade-delay na talaga ang ating, nagpapaywatik na huminto na muna ako. 2.0 ATM multiplied to temperature 318 Kelvin, that's our T2, 318 Kelvin, over 288 Kelvin. 188 Kelvin. So the Kelvin will cancel out. It's 2.04 times 318 times 2.04, that's 64872. 648.72 divided by 208 Kelvin. 208, nangyari, ano to, 208, na space ko pala, that would be 3.19. 3.19. List significant figures, 1, 2, 3, 1, 2, 3, 1, 2, 3. That is 3.19 ATM. Alright, let's check the pressure. The pressure the temperature increased, so as the pressure, Gay-Lussac's law. So that is 3.19 atm. So sorry again for the problem, and as promised, I'll be uploading the last 4 items tomorrow afternoon. No? And yan, good luck on your exam and God bless. No? Thank you for listening. That's 30 minutes already. Peace out. Bye.